Thanks for joining. This is A10. We'll begin in just a couple of minutes. Hello again. So good morning and good afternoon and good evening, depending on where you are. My name is A10 Lifestone. I'm VP of Product Design at Shift Left. And today I'd like to get into some of the challenges of tracking how sensitive data flows through your infrastructure and how semantic graphing techniques can help automate and provide visualization tools and ultimately help you identify data leakages in your software. So the agenda is going to be first sort of an introduction into what are some of the challenges in modern software when it comes to mapping sensitive data flows, followed by some of the scenarios that are very commonly causing data leakages today, as well as the damage that that can do. And then finally, I'll get into the depth of what it means to do semantic graphing on your software to map these flows. And then afterwards, I'll show you how Shift Left's experience sort of embodies this technique and how you can identify flows in that experience. And finally, some Q&A at the end. So it should be no surprise that there's a lot of data being generated every day in the world today. And as a modern day business, being able to map your use and storage of sensitive data is a critical security practice. Regulations like GDPR, as well as compliance standards that have been around longer, have put tremendous pressure on companies to keep track of information flow and storage. And despite this being a commonly accepted priority, we still see devastating data leaks and misuses of sensitive data all the time today. And the reason for this is as the regulations are getting firmer, conversely, our technology and software practices are getting much more complex. So one thing we can see is modern day software development teams, well, they're releasing much more quickly. And this means there's a lot less time to understand the code or understand how that software is using sensitive data. Architectures are getting more modular. So as we know, microservices is a very popular architectural decision that a lot of companies are making right now. And this silos the software itself, but also silos the knowledge of the human beings who know what that application is doing. Followed by more common uses of third-party libraries and open source software as we rapidly build our applications. And this further increases the complexity and our ability to understand what is happening to sensitive data through those APIs. And finally, these regulations like GDPR. which basically is forcing companies to classify more kinds of data as sensitive and trying to figure out what that data is doing in their infrastructure. In a modern microservice architecture, there are now several ways data tends to flow within and outside of your company. And this has introduced several common data leakage scenarios. So here we can see, inside a sort of virtual data center, several microservices, microservice A, B, C, and D. And, through internal API relationships, they're likely passing different kinds of sensitive data between them. So there could be a credit card processing, so credit card information. There could be personal identifiable information like social security numbers. And finally, there can also be, depending on the domain of your business, sensitive medical information passing within your infrastructure. In addition to that, you're of course displaying data back to your customers over the web, and you may be leveraging, over APIs, external databases, so cloud storage solutions like AWS S3 or Oracle. And in these types of architectures, there are a lot of common issues or common scenarios where data leakages are possible. One very frequent example that we see every day is companies accidentally logging sensitive data. Most recently, there are some announcements about passwords being saved to a local log to disk, but we can also, quite by accident, save data to an external logging system like Splunk over their cloud service. We see frequent issues where, sensitive authentication keys are being saved out to places like GitHub. And of course, if you're generating events in Salesforce, it's very possible to include inside those attributes that you send sensitive information that is not meant to be shared externally to your company. So, the key way that we believe is the future of how sensitive data should be tracked is by using an inside-out approach of first understanding how that sensitive data manifests in each application or microservice and plotting its pathways in the application logic as a semantic graph. In other words, analyzing an app source code and building a database of all information flows. Once you can do that, then you can understand how your application logic handles that data, as well as how that data is flowing through open source dependencies or web frameworks that you're using, or even calls that are being made to the lower level virtual machine. So I'd like to kind of look more deeply at this technique, this graphing technique, and its advantages through an example single information flow. So if we look from left to right here, this is kind of a commonly understood directional information flow within a piece of software. And we can see that this typically starts with something that we call a trigger. So this is a method or function call in the application that begins the flow. The trigger itself can receive data input. So if we're thinking of this as a web application, the trigger is commonly going to be a web route or controller action of this software. And so that might be receiving parameters from the web. But in addition to that, as the data passes from method to method, there may be other queries that are happening and data being pulled in from a different source, like a database. So between the beginning and the end of this flow, there may be several transform functions. So a transform function is essentially any logic that touches the sensitive data on its way out to the final saving function at the very end. And that saving function is what's saving that data to an external entity outside of this piece of software. So that might be sending it over an API relationship to another internal or external service, or saving it to a database or a file. So one thing I want to point out is, the key thing here is the data itself. So if we look closely at the data model, you can see here in this example, there's a person class or a person object with various attributes about them. And one of the key things that is difficult to do with traditional security tools is understand the data from a semantic perspective. In other words, being able to automate and understand what data you actually have in your software. Today, this is typically done by watching the perimeter, watching the network, looking at the contents of data packets, and trying to interpret what it's seeing. So it'll see a number go by and it'll try to determine, is this looking like a social security number, or perhaps this looks like a credit card? And one of the challenges with this is with the traditional tools, first of all, there's a tremendous amount of technical overhead in doing that. There's also a very high probability of false positives where it's misidentifying what these things are, which creates more human overhead as well. But instead, if you're mapping information flow within software, if you take the time to also try to recognize the names of variables as you're building this graph, then you can use some form of natural language processing to understand what is the nature of this data. As you've built this database, creating a semantic reference to all of it, and then you can create all sorts of rules about that to determine, based on your company's tolerances, is this something I'm comfortable saving to a database? If it's payment data, perhaps not. Or you can start to query it against transform functions and decide, you know what, if this piece of credit card data is not passing through an encryption routine, which we call a transform, then it's also unsafe. So this really brings me to my final point, which is, if we imagine thousands of data flows like the one I just showed you, assembled into one graph, a database effectively of relationships with semantic understanding built into that of what kind of data is flowing through it, then we can start to query it. We can query it just to get visibility and understanding of where data is going in our infrastructure, and we can query it to identify security issues. So as far as understanding goes, at a minimum, you need to know what kind of data we have, how is it entering our system, which is called entry points here, how is it exiting the system, which we call exit points. You want to know whether there are practices going on that are not approved, so those might be data leaks. But another interesting advantage of querying a graph like this is you can think of most vulnerabilities. In this case, the examples are open source software vulnerabilities or any generic typical software vulnerability like an injection vulnerability, perhaps SQL or a command injection. Really, those two are detected as data flows, because when you think about it, just about all security issues with software involve inputs that are coming in from the outside that are not being checked or sanitized, which lead to the ability for an attacker to take control of your system. And so we can query the same graph database to uncover these common vulnerabilities. And all of this together, we call security DNA at Shift Left. So I'd like to show you a demo of our software to give you some examples of how this technique works in practice and ways that we visualize some of these concepts in a user experience. So let me just quit out of here. Okay, so right now we're looking at the Shift Left dashboard. I've logged in just recently, and on this dashboard we see two applications that we are monitoring. So one of the things I kind of want to instill right now is the Shift Left approach really is two insertion points. One is the analysis of the application from a code standpoint that builds that semantic graph I was describing. But the other part of this is ongoing monitoring at runtime using that semantic graph, so that if an application is deployed in production, we can also see if any attacks are actually happening at runtime that leverage any of the vulnerabilities or data leaks that were detected from the analysis side. So really the marriage of these two data sets, we believe, is truly a holistic way to secure an application and understand the data flows and its behavior in real time. So if I click into this application, we can see that I generated a little bit of traffic. So the very first data element we're looking at is the application throughput chart. And so with this traffic, we see some red lines show up, which are security issues that have been detected. And on the left-hand side, we see triggers for this application. So for that throughput, we've divided it by methods that trigger the data flows, as I've described earlier. And because this is a typical web application, these triggers are named based on the web routes that call those methods. And finally, on the right-hand side, we have data destinations. So these are the places that sensitive data has been cataloged and sent to a variety of data sinks. In this case, we see a few kinds of data that's sensitive going to the log. If I keep scrolling, we'll see some data is saved back to the web, perhaps displaying to the end user. And if I continue to scroll, there are other data destinations as well. So right away, I'd like to dig into a particular use case where here I'm fairly concerned that payment data is being saved out to the log file. So if I click on that, we've now filtered the whole experience. So if you look at the top here, these filters say I'm looking at the application summary filtered by log as a destination and payment data as a data category. And now if we look at the right-hand panel, we see actual variable names, Java variables, that were, first of all, classified semantically as payment data and are being saved out to the log. And they're all highlighted as red because these are all considered a data leak based on this policy. And the policy is essentially something that happens out of the box when you run shift left on a piece of software, but that policy is tunable as well based on the needs of your organization. I'll just quickly mention that triggers has filtered as well. So now we're only looking at endpoints into the application involving payment data being saved out to the log. So I'll click on one of these examples, account number. And here we get to the deepest depth of what shift left can show you visually about what's going on with this particular data flow. And here we're looking at the data flow trace view is what we've called this. And we can see now line of code level visibility into how a particular method was the trigger of this data flow. We can see the initial name of the variable, account number, that was detected and initialized from the beginning of this flow. And then each of these steps afterwards shows you all of the transform functions or any functions that effectively get past this data. It might be concatenated to a string, it might be going through another operation and changing a little bit, but we track it all the way through until at the very end here is the save function. And so here we can see the logging system is receiving that account number as a param and effectively causing a data leak. So this is a pretty exciting view from my perspective. If you consider that, when we started on the dashboard or the app summary view, we're looking at a very operational lens into what is happening at real time across multiple applications. But then we quickly get into this level of detail where we have almost a developer view into what's going on. And I could very easily cut and paste this into a Jira ticket and file it away for a developer to go fix. Meanwhile, in production, an operations person can go and at least mitigate what's happening in real time, perhaps stopping this application if you can do that, or making another change. I'll just quickly go back to the app summary view to show a couple of more concepts. One thing I had mentioned earlier in the presentation is by building a semantic graph of data flows, of course we can use that to show data, but as I said earlier, because of this technique, as a way to understand all inputs, what those inputs go through from a transformation perspective, we can also use that to detect injection attacks or other kinds of vulnerabilities. So if you look at this example, this middle widget groups all vulnerabilities or security issues by common OWASP categories, like injection, sensitive data exposure, cross-site scripting. And we see 35 locations in code where an injection vulnerability is possible. And we see one occasion in runtime where this injection incident was actually detected for real. And so if I click on it this way, we get to the violation detail view. This is more of a management experience where each violation that's generated, while you can kind of visualize that as data flows, you can also treat that as tickets to go assign to people, or I can mark them as fixed. And there's a code component to it, so this might be how I assign it to a developer, but there's also a runtime component to it, so I could at least claim that it's mitigated at runtime for now. And the violation detail view also includes the data flow view I showed you earlier. In this case, instead of the view being focused on a data leak, it's focused on an injection vulnerability. In other words, an input that's come into the system and is not going checked until making its way to a query. So the final thing I want to show you is something I'm very excited about that we're building right now, which is and I'm going to switch over to a MockUp Experience. Not only can we show data, flowing through a single application, but we can use these techniques I've been talking about to visualize pathways of data across the whole topology view in a topology graph like this. And this is a pretty key way that I believe people in the future are going to just absolutely need to track how data flows, because as we know, with microservices becoming more and more popular, you can't really treat an application as a single application anymore, but really these are cells that are part of a larger organism. And so in this particular case, we see a variety of microservices that are communicating with each other, as well as with data syncs, in this case, a text file and a database. And I can hover over on the right-hand side any data category, and we can quickly identify pathways that purchase data, in this case, is taking through our infrastructure, all the way out to a data sync, that text file. Or if I mouse down to PII over here, we can see how PII data flows through almost all of these microservices. So this is a pretty exciting view, and there's going to be other capabilities where you can select multiple things and define policies or tag those things, and really help you ultimately manage how you choose to lens your entire infrastructure as you explore where sensitive data is going throughout those pieces of software. All right, so I'm going to switch back to my presentation for a moment. Oh, starting at the beginning. Bear with me. Play from current slide. So one thing we want to point out is we're offering a free data leakage assessment to companies who get in touch with us. And so what this is a PDF report, which I'll show you a sample of in a moment. But basically, we can use the same engine that's powering the user experience I just showed you to give you a comprehensive PDF document that lists all of the places sensitive data is detected in the software. So there's a URL here, and we're going to share that, I believe, as well to all the people who have registered. And here's a sample of the report. So there is a summary you get at the beginning, which gives a high-level perspective of what sensitive data is detected in a piece of software and how it's tagged based on certain common data categories like PII, and then followed by a table that will give line by line where the sensitive data is detected, any transformations it's going to, and of course, the data syncs that it's being transmitted to. So a pretty useful report that you can hand off to your leadership in your company. There's the URL one more time. So at this point, I'd like to take questions. So I'm going to flip over to, let's just show this view while I flip over to the question panel. Okay, so one of the questions is the product specific to Java applications? So the answer is no. We're going to be, we support 2 languages right now. Java we have supported since the beginning, but right now we also support .NET and C#, of course, as part of .NET. And then in the future, we're going to be rolling out support for other languages. So I think the order of which might be first Golang, after .NET, followed by, in no particular order, languages like Python, probably missing a few, server-side JavaScript, and potentially Ruby on Rails. So I'm looking at another question here. There's a few, bear with me. Does this tool identify a vulnerability? So yes, hopefully I've shown that in the example. I can't tell when this question was posted, but yes. So because of the way we map all data flows, it's an excellent way to be able to query and reveal common vulnerabilities. So yeah, I showed you one example of that as an injection attack. Okay, so can you please speak to how your software can be embedded in other stacks? So hopefully I'm going to interpret this correctly. But one of the common questions we get is, does this technique work with software deployed in containers? Will it support cloud solutions like an instance running in AWS, as well as traditional data centers? So the answer is it's very, very flexible and will work in almost all stacks. The reason for this is because of the method of insertion. So one method is the analysis side. That would be integrated with your CI/CD pipeline. So as part of, let's say you're using Jenkins, with every build, you run a command line script that does the analysis using the shift left engine, and that's the first part of it. The second part is in runtime. We use an agent-based approach, which is very common to APM solutions. If you've used something like New Relic or AppDynamics, it's essentially a jar file that runs along with your application. So it's not a separate process that runs on the machine, but it's really inside the JVM with that app. And I speak more confidently about Java than .NET because I know Java. But basically, because of it accompanying the app in the JVM, you can really run it anywhere. It doesn't matter whether it's a container, a typical Linux box, or a cloud vendor. Let's see, reading. Sorry, I'm laughing because people are also apologizing for asking questions now. It's fine. How are you? How are the? Let's see here. Oh, application insights. I'm not familiar with that one. Oh, I see. Okay, yeah. So application insights from Microsoft is an APM solution. There are similarities in the technique of instrumentation of the application. But their solution is an APM one, so it's monitoring performance. So you'll see stats like response time and throughput, but they're not building a semantic graph of data flows, and so they won't be able to show you the kinds of vulnerabilities or insights into sensitive data that you're seeing in this product. Yeah, so a really great question. Can this tool be compared with other industry static tools in terms of identifying vulnerability? So the word static is kind of a key word for me. So if I spin this the wrong way and I misinterpreted this, I apologize. But you may be referring to static code analyzers. So the way we differentiate, or the way I would explain how this is different from that, is by first trying to classify two kinds of static code analyzers. One looks for signatures, which is kind of more like a virus scanner. So if there are known vulnerabilities out there in the database, it will scan your open source software and potentially your source and see if versions of whatever frameworks you're using are out of date and are known to be vulnerable. It might look for patterns in other ways. The issue with this is it's kind of no better than a typical virus scanner you would see on your computer. It's not going to find unknown vulnerabilities, or in particular, if a developer has made a mistake and accidentally logged sensitive data to file, obviously it wouldn't be able to detect that. But of course, even with traditional vulnerabilities, if your developer has done something very custom and introduced a deserialization vulnerability, it won't really find that. So the other kind of the static code analyzers, they do try to map flows within the software. The ones that we've looked at are all using a very slow technique. So for example, when we talk to certain customers about the static code analyzers they are using, the typical answer we get from them about how they use it is they're scanning once a year, maybe once a quarter at most, because they're very, very slow. So we've built a new technique involving the semantic graph as a very, very performant thing to generate and a very performant database to query. And that's what allows us to integrate much more seamlessly into an agile development lifecycle. So maybe one thing I should point out that's very unique to our solution is we integrate right with a CI/CD process from a technical and a human standpoint, and you can seamlessly analyze every version of your application. as builds are constantly being generated and deployed. The other thing I'll mention about static code analyzers is you almost never see them combined well with a runtime protection solution like the one I've shown you here. And so this special advantage that this solution has is any insights that are derived or extracted from the analysis phase automatically configure the runtime protection, which makes it highly efficient as a way to only instrument what we believe are vulnerable endpoints based on that that first step of analysis. Let me go through some other questions here. You're welcome. Someone said thank you. Well, okay. Someone asked a question and then. Okay, so yeah, I'll answer this one. So it's like a two-part question. How are the pathways monitored, proxies or agents only? So the way this would work is, the analysis obviously builds the semantic graph per application, and then the agents themselves would be the ones showing how it interconnects. So a proxy would not be necessary. You wouldn't have to run an extra app or service on each box to help build that network. Okay, another question was the same one, so hopefully I've answered that. Right, this is a great question. Sorry, it takes me a while to read these. Can I incorporate this into the development cycle so I can know of any potential issues as new code gets checked in? So the answer is yes. We very much hope that this is how easily it can be integrated in the development lifecycle. So the way I would explain this is through maybe a very common question I get, which is once we show them the solution, in particular because it combines the analysis and the runtime, and so you see it sort of blended as, hey, here's some vulnerabilities and here are some ways you're being attacked. In this example, a very common question is, well, wait a minute, am I going to have the opportunity to fix these issues before it reaches production? So in that particular case, the kind of best practice is whatever is your pre-production environment or dev environment or staging environment, you would run shift left entirely on that as well as on the production environment. And so what will happen in that case is as code is checked in, if you have a sort of a seamless build cycle where you'll automatically create new builds as new code is checked in or PRs are checked in, shift left can be in that sort of smaller cycle, so that if there are very severe vulnerabilities that you want to fix before anything reaches production, you have the freedom to do so. But as we all know, across huge teams, hundreds or thousands of applications, we can't fix all vulnerabilities before they reach production. So you can kind of decide what is the risk reward of tackling certain things. But then if it does reach production, there is still this sort of protection mechanism built into this solution as well. I'm just reading through another question here. Right, so there's a question about false positives. So yeah, this is one of the key reasons we started this company, is because of how much false positives are problematic in other solutions or other security practices. So the answer is there should be no false positives in the solution because of the way we combine code analysis with runtime. Anything you see in production as an attack is confirmed as real. So that's pretty exciting to us. Reading through more questions. Sorry if I go silent, it's because I'm reading. Oh, this is a long one. There's a question here I want to acknowledge. On-prem or cloud solution. I don't want to speak to specific other vendors, but what I'll say is that there is a part of this question that's also about, Java agent would be installed on each standalone server container or individual microservice. How does this software build data flow combining inputs observations from each agent? Yeah, I mean, so it's not a simple technique. If the agent-based way to build these relationships often involves the agent implanting something in the packet headers, an identifier, and that identifier being picked up by other microservices that are also running that same agent that are looking for that identifier. That's a sort of high-level, simple explanation for it. There are a lot of gotchas with that, so it can be more complicated than how I just described it, but that's the sort of fundamental core of how that relationship diagram is detected between microservices. Yes, it does not matter which data center or whether something's in a container or not. It's more dependent on the protocol that the microservices are using to communicate with each other. Right, so there's a question here. The code is analyzed at build time only, not at runtime. Is this correct? Example, it's not a live debugger. So you are correct. It is only analyzed at build time, and runtime is the part where it's watching so it's automatically instrumented certain parts of the application and just looking for whether attacks are detected for what it's found at build time. So it is indeed not a live debugger. There are other security tools where you actually kind of have to QA and probe it in production or some sort of testing environment in order to get the analysis done. That is not how our solution works. The reason why we didn't go that route is because the sort of QA method of getting your code analyzed and instrumented is only as good as your ability to QA it, which we know will not be fully comprehensive. See here. Is there an API? Yes. I don't know specifically what you're looking for, but obviously solutions like this need to fit into the operational context of the teams that want to adopt it, and they have their existing tools, right? They have ways they want to dashboard things. They have alerting systems. Maybe one thing I'll speak to, which we're pretty excited about, is and this isn't really the API question, but I'm weaseling an answer in to someone who didn't ask it, which is if you go to our alerting system, obviously a lot of teams use other alerting systems or maybe PagerDuty, so we will have APIs available, and so those can be integrated. The other thing I'll mention is sort of the developer side of things. So I pointed out earlier we have this violations experience, and you want to assign this to people or mitigate stuff. And you can fully manage that within the shift left experience, but we also, of course, realize that development teams are using ticketing systems like Jira or GitHub. So one of the things we're currently working on is an integration with Jira that will allow synchronization between violations in shift left and tickets in Jira. So if they're resolved there or assigned to someone there, that reality will be reflected in this experience as well. So that would be pretty cool. Let me open up the question thing again. Oh yeah, so similar to the API question, logging out to Splunk, SIMs, syslogs, so forth. What this person means is, can events just come out of this product so that if you have your own SIM or logging system that you're building analytics on top of for security purposes or other purposes, yes, of course, we definitely believe that that is going to be a common request. And so this software will log out events, and then they can be consumed by other products like Splunk. Hey, it's a popular question. hopefully I've answered. So someone else asked the same question. Right. So, the API, looking for a way to programmatically access the output data, same as in the user interface. Yeah, so because of the way we've architected this app, all of the UI-driven experiences have very well-defined APIs, which we can expose to customers. So, if you want to programmatically script how you react to vulnerabilities being generated or data flows being detected, you should be able to do that. There's a question about what is deployed and where. So I had to read it a few times. So I think I guess what you're asking is to be fully instrumented by shift left. What does that mean? What do you install where? So, I think the primary thing is running the agent and deploying that agent with wherever that application is running. That in the Java world, which is what I'm comfortable with, that should be as easy as including another jar with your application. And you likely already have in your deployment ecosystem a facility for including dependencies or whatever with your application. So we would just be another one of those that runs with it when you run the app with an extra flag to say include the shift left agent. As far as the analysis side goes, that would be a command line tool that should be accessible to your Jenkins or your build pipeline system. And you would add just another script to that build pipeline whenever a new piece of code arrives, so to speak, or whenever a new build, quote unquote, is generated, whatever that means to you, you would then trigger the analysis to happen via the command line tool. The good news here is the analysis runs very, very quickly compared to other solutions you might have heard of. So it should feel pretty seamless once integrated in that way. And then when you trigger the deployment, so packaging things up and sending it to wherever it runs in production, the agent is included with that. And the agent should be configured based on the analysis, but a lot of that happens in the cloud as well. So I can't speak to more detail than that. Okay, sorry, I'm still reading another long question here. Okay, here's a good one. So I think it's a follow-up from an earlier one, but I know you can't talk about other vendor products, but you do agree that it is relying on instrumentation techniques. One of the biggest advantages of microservice architecture is scaling. How does licensing work when you have to auto-scale? Yeah, so really good question. Right now I don't have like dollars and cents with me, so I can't speak to that. But if you follow up with us, I'm sure we can get much more specific about how licensing should work. I can say philosophically, we want to be very accessible and cloud friendly to companies that are adopting cloud. Obviously, if it's an astronomical price point per quote unquote application and you're auto scaling, the economics probably don't work. So what I do know is at least the leadership here philosophically very much wants to be cloud friendly in our pricing and our instrumentation methods and so forth. So the question about instrumentation technique, advantage to Microservices. Okay, actually one more thing about the pricing is just what we're trying to do is somewhat model pricing that people are already used to when it comes to their cloud hosting solutions. So you can imagine how AWS bills use of instances in AWS. We're going to try to model similar to that, but beyond that, I can't speak with authority on it right now. So as far as instrumentation techniques, the scaling question. So I'm probably answering something you weren't intending to ask, but so the concern is, yeah, as you auto scale, is that going to just cost you much more money? So hopefully I've addressed that a little bit. But the other question is just, the overhead of the instrumentation technique. So maybe you didn't intend to ask this, but I'll answer it anyways. One of the key concerns that we get all the time, especially individuals who are used to working with APM vendors, is how much overhead, how much slowdown can I expect when your agent is deployed and working with the application. So we have been very conscious of that concern since day one of us implementing our solution. And the good news is that the runtime agent we call a micro agent because it's much, much more efficient than an APM agent. And so the overhead, while I can't give an exact statistic, it's magnitudes less overhead than a typical APM agent like New Relic. The reason for that is because an APM agent has to monitor and instrument everything in order to give you a picture of performance. If it doesn't do that to depth, then you're not going to get an accurate measurement of performance. In our case, since that's not quite the focus, we show minimal statistics about throughput and activity because that adds to the context. But we only deeply instrument and monitor certain endpoints that we were detecting as vulnerable from the analysis phase. And so that's what allows us to be incredibly efficient and have low overhead. Okay, I can keep going. I'm going to do this till my voice box falls out. Okay, there's another question about events logged out to Splunk from shift left. So yes, that's doable. So here's a good one. If microservice has different inbound, outbound IP address, the solution may not correctly work. Actually, it will work because of this technique, the agent doesn't require stable IP addresses. All it needs to do is put the right identifier into the header of the communication protocol used between two microservices, and then it's picked up by the agent at the other end. So it really does not matter what proxies or networks or IP address changes are happening. So that's the good news about that approach. One question about the scan is automatic, or do we need to initiate the scan? So you can choose to initiate it manually at the command line, but it's really meant to be automated. If you're going to do the build integration, then we imagined it used in an automated way, in a script way, and it should be pretty straightforward to do that. I would love to do another. I would love to do another of these webinars where we just show the detail of like what day in the life. What does it mean to at a script level, if you're using Jenkins, what does it mean to automate security? That would be a really cool webinar to do in depth. Okay, it looks like so there's a final question here. I don't think I can answer properly. It just says, what kind of attacks is shift left able to detect other than OWASP? Do you get threat intelligence data feeds? So no, I don't think we do, but we definitely detect attacks like injection attacks on those vulnerable endpoints. I wish I could be more comprehensive in my answer, but I felt like I needed to address it since it's the last question in this list. So I guess I'll end by saying thank you everyone who attended. Hopefully I've given an interesting perspective on what we believe is the future of tracking sensitive data in modern software. Hopefully you found the demo of shift left interesting, and thank you very much for the questions. Don't forget the GDPR report offer, so we'll send that link out to those of you who registered, and I wish everyone a good day wherever you are. Thank you again.